we'll create a GPU-enabled Cloud Run function that will directly host a Gemma 2 2B model downloaded from the Hugging Face website. I'll also show you how easy it is to leverage Hugging Face Transformers Python library to rapidly build AI-powered applications with Cloud Run. Let's get started. First, I will create a Cloud Run function via the UI. Let's go ahead and give the service a name. And we're going to choose Python as our runtime. Let's go ahead and make the public endpoint public for the demo purpose. And choose the CPU always allocated. Under the Containers tab, I'm going to go ahead and configure this memory and the CPU required for this container instance. And we'll attach an NVIDIA L4 to this. Let's go ahead and set concurrency to be 1. All right. Next, let's go to take a look at the Variables tab. Here, I'm setting up 2 environment variables. The first one, it will be a LD library path. That's going to point to the path for me to access to the CUDA drivers. Next environment variable, I'm using the secret manager to store my Hugging Face token, which is needed later on for me to download the models from the Hugging Face website. Let's go ahead and create this Cloud Run function. Now, it's going to take a few seconds. All right, so the Cloud Run function service is created. Let's jump right in to edit our code. First, let's put in some of the requirements needed for this app. And then for the main logic of this application, instead of writing any new codes, let's go ahead and go to the Hugging Face website here. We're going to copy the code over into our function's event handler. All right, so let's copy the code here. Let's go ahead and fix the indentation. And then we'll move the imports to the top of the file. Let's update the device map to CUDA. So here, we are leveraging the Transformers Python library to interact with the Gemma model. And then I'm asking Gemma to help me write a poem about machine learning. And also note the maximum output token here is set to 32. So expect the poem from the Gemma model be truncated. All right. So far, most of the code is based on the existing samples, except we made a few tweaks here and there. And we didn't even need to write any new code. Everything looks good. Let's go ahead and save and deploy this Cloud Run function. In the interest of time, let's go ahead and switch to this pre-deployed, pre-built Cloud Run function. Here, you can see the source code is identical to the one we just deployed. Now, let's go ahead and actually invoke this endpoint. Since this is a warm instance, the Gemma model responds quite quickly. As expected, poem is truncated because of the token setting in the sample code. All right, so we've done it. We have successfully demonstrated the Gemma model running on a GPU-enabled Cloud Run function.